Welcome to the new Edge Open podcast, this time on the topic of unleashing edge innovation with the Qualcomm Robotics RB5 development kit. I'm Ilhana Hodzic from ADLINK EMEA Marketing, and I'm thrilled to have two extraordinary guests with me today. Jean-Jacques Adragna serves as Staff Manager, Product Marketing and Business Development at Qualcomm EMEA. On the other hand, Richard Pinnow is the Business Development Manager for Modules at ADLINK EMEA. So, let's kick off at the start. No better person than Jean-Jacques to tell us a bit more about what are the trends and use cases driving Industry 4.0.
Thanks. Well, two big trends actually. The first one that we can see is the adoption of new technologies that are more consumer and enterprise driven, like edge computing, AI, machine learning, digital twins, XR, and autonomous robots. And the second one that we see is the global requirement to increase productivity, which is very natural, of course, but also in a wider sense, improve operational efficiencies. And that can be very diverse, like improving the supply chain visibility and flexibility to adapt to demand fluctuations, or improve your sustainability and reduce your carbon footprint, or improve and optimize the lifetime of legacy equipment, digitize operations, and also provide operators with modern tools that improve their visibility, their efficiency, and make their life easier in a way. Another trend is that, of course, to do that, you need a fabric, you need a common infrastructure for the industry, typically being 5G on the factory floor. So let me mention a few use cases, and globally, that's the connected factory, where you want to improve your operations by having machines that are more connected and improved communication flows in between them, and also flexibility to reconfigure that allows you to adapt to changing production orders, for instance. Then you want to use robotics drones, so autonomous robots that make operators' life easier because, for instance, they can lift heavy weights and transport them autonomously through the factory, or autonomous drones that can go where the people cannot go to perform quality inspections. And I can also mention the global use of AI in the factory to perform operations like predictive maintenance, so where you use sensors to report conditions and parameters of your machinery that allow you to have longer time in between maintenance, or to predict a failure in advance. And you can use also or reuse your surveillance cameras to improve the safety of your workers, because you are now able to detect flames, smoke, make sure that your workers wear their safety equipment, for instance, and you can also improve your quality control. And what's very important is that all of that can be done at the edge, locally, with very good respect of privacy, security, confidentiality, and all of that with high risk, with very, very low latency, which is also very important on the factory floor.
All of that sounds very interesting. Thank you very much, Jean-Jacques. Also, Richard, would you mind telling me how ADLINK supports engineers and customers today so they can get started?
Yes, of course. So, first of all, we are more than happy to have the Qualcomm RB5 platform in our ADLINK Smart module lineup. That's great. So, and it remarks in this area of performance. That's great. And what we found out is that the success rate of really brilliant ideas is often depending how fast you can move from the concept to first tangible results in form of, for instance, proof of concepts. So ADLINK, so our mission is to put engineers and customers on the fast lane by following really 3 core principles. Number 1 is standardization. Second is providing ready-to-use data kits, and third, localized design services and support, of course. So to the first point, standardization. ADLINK is fostering standardization in form of computer modules since more than 2 decades already. So we really believe in open compute standards like OSM, SMART, COM-Express, COM-HPC, because only this approach really guarantees long-term scalability, maintenance, availability, and real second source options. So standardization is really the key to significantly shorten time to market by really application-ready function blocks in form of these computer modules, which can be quickly implemented in a very broad field of mission-critical use cases, like you've mentioned, Jean-Jacques. Customers can really concentrate on their mission and their core value proposition without wasting time for this complex CPU and memory and SoC implementation. Secondly, ADLINK's Qualcomm RB5 ready-to-use data kit follow the so-called IPI SMART ecology, which we funded, which makes it really easy and super fast and nimble to getting started with this top-notch Qualcomm platform. So the module itself follows the SMART standard, that's great, which is nothing more than the most versatile open compute standard at the moment for compact embedded designs with up to 15 watt thermal design power. And interesting fact, by the way, SMART is enjoying the strongest annual growth rates. So that's nice, and even a very good argument for customers to go for SMART. And the Qualcomm RB5 feature set itself matches very nicely with its base feature set, the SMART standard. On top of this, we implemented 4 additional MIPI-CSI cameras connectors on the top layer, which make all 6 camera interfaces user-friendly available. And as you can see, we are not just following the SMART standard, we are driving the SMART standard of one of the funding members of the SMART standard. As initially said, starter kits follows the IPI SMART ecology. Well, you might be wondering, what does it mean? What does IPI, what does it stand for, right? Let me share some light on that. The module itself is useless without a carrier board, right? It's first of all just a computer on module with goat fingers. Computer on modules are always required to be mounted on a carrier board, which then breaks down or out all the module interfaces to standard peripheral connectors on the end customer carrier board then. And that's basically the clue. The carrier board reflects individual project-specific IOs, interfaces, additional memory devices, for instance, and connectors, according to the customer application requirements, which can be very, very different from project to project, while the computer on module always, itself remains a commercial off-the-shelf solution. And in this context, let me get back to the IPI story. To enable clients quickly, ADLINK predefined a very, very compact and nice reference carrier board so that you can jumpstart your project, your proof of concept today. So the carrier board provides a lot of common Raspberry Pi hardware interfaces, which is nice because a lot of useful maker accessories can simply be reused with this industrialized rapid prototyping starter kit. And most importantly, it doesn't stop with hardware. Our IPI SMART comes along with EMEA hardware abstraction layers, ready-to-use operating systems like Linux, Yocto, Ubuntu, and others. I really strongly invite you, if you want to learn more, simply check out the IPI offering on www.ipi.wiki. Don't get confused, this site 100 belongs to ADLINK, and one can easily buy the Qualcomm RB5 IPI starter kit online. And you can check out via PayPal, credit card, it's very easy, and you can getting this one shipped elsewhere in the world within 2 weeks. And last but not least, the third and most important pillar of success is our local for local design services and support. So ADLINK is headquartered in Taiwan with local production support and R&D subsidiaries all around the globe. This allows us to serve our clients in the same language, in the same time zone, with local design and production and value-add services. So yeah.
Oh, wow. Wow, Richard, sounds awesome, really. So then I'm really curious to learn more about how Qualcomm can help businesses innovate and address evolving robotics and edge AI applications. So, Jean-Jacques, the stage is yours.
Yeah, you know, we are constantly innovating at Qualcomm to enable those new use cases, and we deliver solutions that address the common criteria of those applications: very small form factors, energy efficiency, and high performance. Also, the ingredients, the technological ingredients that are part of every chipset, every solution that we deliver are intelligent computing with edge AI, and I've mentioned some use cases in the previous question. Best-in-class wireless connectivity, and you know how much Qualcomm is leading that domain, as well as built-in security to enable those new and innovative industrial applications. Again, very important to do that processing at the edge instead of doing that in the cloud. And this is where those very powerful yet power efficient chipsets help. So let me give you, for instance, a few points about the QRB5165, which is the system on chip at the heart of the LEC RB5 platform that Richard has described just before. So this is a processor that we customized very specifically for robotics and edge vision applications. It offers an heterogeneous computing architectures that, of course, offer a usual 8-core ARM processor running at more than 2 gigahertz, but also Qualcomm artificial intelligence engine that delivers 15 trillion operations per second of AI performance to run those AI and deep learning workloads locally on device. Part of the resources that are available on the chip to run those workloads are the image signal processor that supports up to 7 concurrent cameras, a dedicated computer vision engine for enhanced video analytics, as well as our Hexagon tensor accelerator that alone delivers 8 tera operations per second for those AI workload, and it's complemented by our Qualcomm Adreno 650 GPU. So again, some data points, numbers are impressive. Our image signal processor, the Qualcomm Spectra 480, can manage up to 2 gigapixels per second pipeline. 7 camera concurrency, I already mentioned, 200 megapixel photo capability, 8K video, 4K HDR capability that allows robotics and autonomous drones use cases. All of that, as I mentioned, is the compute side. We have the security side that allows starts with the crypto and key management applications, but goes all the way to DRM that allows to manage and enable features on a per device basis, for instance, and connectivity with Wi-Fi 6, as well as cellular options for 4G, 5G, and private 5G, which is a critical element of modern connected factories. All of that, you need to do it while supporting the very demanding industrial conditions, of course. So the chipset is specially qualified to support high temperature range, up to 105 degrees junction temperature. It has long life cycle support, and it supports industrial protocols like Ethercat and in the future TSN. And because it bears all of our mobile heritage, this is a low power chip, very flexible power management approach that allows you to either run those fanless edge boxes that are going to process multiple video flows, but also develop battery operated applications like AGVs or autonomous flying drones. This is very important to have this low power as well as long life cycles that we can ensure with that chip to support sustainable applications on the field.
Many thanks, Jean-Jacques, for the very insightful thoughts. And that reminds me to ask Richard the following. Does ADLINK provide schematics and BOM list of the reference carrier?
Well, ADLINK believes in the open source approach to really boost time to market, which is essential nowadays, right? So to really reduce the customer's total cost of ownership by using and reusing pre-qualified function blocks. So, of course, this includes design resources such as schematics, a bill of material list, and layout snippets of our reference carrier to really shorten time to market of all of our customers. So customers can copy a lot without the need to start from ground zero, right? And we all make this public available online. So you can simply go to ipy.wiki. You can simply download all the reference carrier data. And in case you need any assistance to getting started with your customized system, just let me know. So it's my pleasure to introduce you to our solution architects and field application engineers in order to get you all the necessary details on the fast lane, right? And in case you got stuck during evaluation or design in, again, ADLINK really don't let you down until your project will really turn into revenue for you. So our support comes along not just with FAE and solution architect support. We have really vertical certification expertise in-house. We can provide schematics review when you're ready with your schematics. Even the layout review is possible. And as I said already, local for local hardware and software end-to-end design services. And again, as I said earlier, SMART modules really, SMART is a good way to go. The SMART modules truly stand out with their rich choice of graphics, camera interfaces, sound interfaces, networking, and optional wireless interfaces, and much more, of course. And this really perfectly fits to the unique AI-accelerated Qualcomm RB5 feature set.
So many relevant information. Thank you, Richard. And as the last point in today's Edge Open podcast, our audience might want to hear what software tools and support Qualcomm offers to support these developments. Jean-Jacques, would you like to get more on this?
Sure, and good complement to the hardware point that was developed by Richard. We have tools available on the Qualcomm Developer Network to help customers build the applications they need by delivering the full potential of our platforms, combining the hardware capability and good software. This is going beyond simple development tools and really enabling our IoT customers with production-ready software development kits and allowing quicker product readiness. So let me give you 3 examples of that. We have our Qualcomm Robotics Vision SDK that provides localization and feature recognition and obstacle detection that helps robotic developers utilize the full capability of the platform for autonomous robotic systems. So it supplies the right tools and the right functionality to use our computer vision algorithms that provide those capabilities of localization, feature recognition, and obstacle detection. We have a more generic tool, which is the Qualcomm Neural Processing SDK for advanced on-device AI. So as I said previously, our product have extensive AI processing capabilities, ensuring to allow the running of trained neural networks on device without a need for a connection to the cloud. So the SDK is designed to help developer run one or more neural network models that can be trained using standard formats like TensorFlow, PyTorch, or ONNX, and then run them on the Qualcomm platforms, flexibly choosing the processor that you're going to use on the platform. Should it be the CPU, the GPU, or the Qualcomm Hexagon processor? The last software development kit that I want to introduce is our computer vision SDK that offers rich vision processing and functionality and helps developers add new user experiences on camera-based apps. Let me mention gesture recognition, face detection, face tracking, face recognition, text recognition, and other usages related to augmented reality. Those are high-level middleware, and of course, we provide the low-level tools, Linux, Yocto, Ubuntu, as you mentioned also, Richard, as well as native integration of ROS 2 and AWS RoboMaker for providing the end-to-end robotic application development.
Oh, so incredible, Jean-Jacques. I have nothing to add here, except that it was my pleasure to have both of you at the Edge Open podcast session, especially having in mind that Jean-Jacques has 20-year experience in the design of industrial control and the energy management systems, combined with Richard's extensive industry experience, primarily focused on the embedded product portfolio, also including go-to-market strategy, innovation management, and consultation. Until the next podcast session, stay up to date with the latest Qualcomm and ADLINK innovative solutions by following us on social media, subscribing to our newsletters, the website, or visiting IPI Wiki page. Once again, thank you both, Jean-Jacques and Richard.
Thank you.
Thank you for having me.